So it's nice when they make or give a table for us because then we don't have to figure out where the center of the graph is. We'll just put our table together, graph those points, and then our parabola will be there. So let's look, I'll be on the fraction with you guys. Let's graph this function and then we can compare the two. So it wants us to graph the parent function without anything being like added, subtracted, or multiplied by it. So the parent function is just if you plot what is 0 squared? 0. What would 1 squared be? 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is 4. 3 squared is 9. Negative 3 squared is 9. So that would be your parent function. Nothing being added or subtracted to it. That's the picture of the graph on that front page in the center. So let's look at if we try to graph the one they asked us to, which was 1/4 x squared minus 2. So if we plug in negative 4, so all you guys would do is plug in, and to do a fraction, you would have to do 1 divided by 4 in parentheses, and then we're putting in our x values right there where that x is. So then in parentheses, we're plugging in negative 4 squared minus 2. So when you guys plug that in, negative 4 squared is 16 times a fourth is 4. 4 minus 2 is 2. Then you would plug in negative 2. Negative 2 squared is 4. 4 times a fourth is 1. 1 minus 2. Negative 1. Then you plug in 0. 0 squared is 0 times a fourth is 0. 0 minus 2 is negative 2. Then we plug in 2. 2 squared is 4. 4 times a fourth is 1. 1 minus 2. So you should be getting repeat values because it's symmetrical. So you're going to have these same points. And then when you plug in positive 4, you will get 2 again. So let's go ahead and plot those points. So negative 4, positive 2. Negative 2, 1, 0, negative 2. I plotted that one incorrectly. There we go. 2, negative 1, and 4, 2. So if you compare the blue graph to the gray graph, you should notice a couple of things, hopefully. So the similarities, they have the same axis of symmetry because they're still both centered in the middle of the graph on the origin. So similarities, they have the same axis of symmetry. But differences, well, the blue graph shifted down 2 from the origin. And it's also a little wider because of that 1/4. 1/4 is smaller than 1, so it should be wider or flatter. So the blue function, the 1/4 function, is wider, but they are still opening up. So that would be a similarity. But just things you can see. I can visually see it's moved down, and I can see that it's a little wider, so I would put those things. So go ahead and try the first graph. So it gives you the values to plug in, and you're just going to put them right in there for the x. Remember to do your order of operations first. Square the value you plugged in, then multiply by negative 3. So if you guys go down to the bottom of the page, it's just once you guys go through an exercise of talking about the concavity of a function or a graph. So concavity just talks about if it opens up or down. So we did talk about it a little bit. So for in number 1, it would concave down since A is negative. But in the one we just did, in example 2, it concaves up or opens up because the 1/4 is positive. That's literally all you look at. So you're looking at the number attached to the x squared. So whatever is attached to the x squared tells you, okay, is this going to be opening up or down? So for 3x squared plus 5x plus 8, 3 is positive, concaves up, opens up. But for e, it's negative. It's really a -1, so it would concave or open down. So if nothing else, you should at least be able to tell which way your parabola is going to go. So for letter B, it's a +1. It will open up. Just that alone is a good piece of information for you guys to know, because then you can at least check at the end, is it at least going the right direction? So go ahead and do those last couple.